The standard form of a function depends on what type of function it is. For example, the standard form of a linear function is ax plus by equals c. And the standard form of a quadratic function is ax squared plus bx plus c equals 0. In both functions, the letters a and b refer to coefficients, and c is a constant. Consider the function 3x plus 12y plus 13x minus 22 equals 2. To put it in standard form, we first need to combine the like terms. 3x can be combined with 13x. And the two constants, 22 and 2, can also be combined. The result is 16x plus 12y equals 24. But that isn't the standard form, because all the numbers can be divided by 4. So let's divide them by 4, and this will give us the standard form of 4x plus 3y equals 6. Now, we can see on a graph that changing the original function to the standard form, let's plug that in, does not change its graph. However, the standard form gives us information about the key features of the function that the first equation does not. For example, if we divide this constant 6 by the y coefficient of 3, gives us 2. And 2, see on the graph, is the y-intercept. Similarly, we can divide 6 by the x coefficient, which is 4. That's going to give us 6 fourths, 3 halves, also equals 1.5. And we see here, yeah, that's the x-intercept. The standard form is also useful for solving systems of linear equations. Consider the equation 2x plus 3y equals minus 3. Let's enter that one in. Minus 2x. Let's make that minus 2x plus 3y equals minus 3. Now, if we want to determine where these two lines intersect, we use either the substitution or the elimination method. And the standard form helps us because we can subtract. You see the two equations here. When we subtract 3y minus 3y, we get 0y, which equals 0. And if we subtract minus 2x from 4x, that's going to give us 6x. 6x plus 0 equals 6 minus 3 is 9. And solving for x will give us 9/6. So we simplify that. Yeah, it becomes 3 halves. And that also equals the decimal 1.5. Now, in the next step, we're going to use this number 1.5 by plugging it into either equation, and that will reveal the value of y. For example, 4 times 1.5 is going to be 6. And if we subtract 6 from both sides, we get 3y equals 0. And that reveals to us that the value of y in the point of intersection is 0. The x value, remember, is 1.5. Let's look at the graph here. Yes, 1.5, 0 is the point, the intersection. Now, in order to solve other problems, you're going to use other forms of the linear function. We have the slope-intercept form, y equals mx plus b. And we have the point slope form, y minus y1 equals m times x minus x1. And we note that our first function, going back to the graph here, the line moves downward from left to right. That means the slope is negative. So if we go back to this, our equation here, we want to put this standard form into the slope-intercept form. We're going to isolate, put y by itself on one side of the equation. First thing we'll do is we'll move x over. 3y equals minus 4x plus 6. And then we'll divide both sides of the equation by 3. And you should see that this y equals mx plus b format tells us here that the slope is minus 4/3. And if we're going to go back and put that format into our graphing calculator. And gives us the exact same line. We haven't changed the function. We put it in a different form. And it's a form that shows us the slope and the y-intercept. Now, knowing how to put a function into the right form is the key to solving many algebra problems. I'm an experienced teacher and tutor. I enjoy helping students understand the forms of functions, and I look forward to working with you online.